So we are now done addressing our fourth goal, which is for you to be able to define the different terms used in bridge engineering, especially the different parts of a bridge. So we are now down to our last goal for this discussion, which is for you to be able to define the different structure types used in bridge construction. So in actual bridge construction, actually there is a number of different bridge structure types that are usually used depending uh, on on where exactly it will be constructed. So a wide variety of structures are in use for a variety of different physical applications like human-made, natural, or climatological conditions that dictate the type of structure to be used at a given crossing. This could be in the form of this can be some of the basis for the choice which particular structure type will be used on a particular physical application, whether it is human-made, natural, or climatological conditions. So the first one is the length to be bridged from the start to the end of the structure. So that's one of the bases for us to decide what particular type of structure will be used on a particular location. Another reason or another basis is the depth of channel or ravine to be crossed. Another is the underpass clearance required, the type and volume of vehicular traffic, the extreme temperature conditions, the precipitation or snowfall, curvature of overpass alignment, aesthetics of the surrounding environment, and lastly, potential environmental impacts. So these factors that we have enumerated here can dictate which type of structure will be used at a given crossing. So since we are talking about now on the term structure types, there are actually several types of bridge structure that can be made depending on the location, depending on the location, or depending on the different factors that we have enumerated here. So the first type of structure, bridge structure that we will study is the slab on girder. S- Slab on girder looks something like this. So this is actually the most common type of bridge structure. That's why we will be more focusing on bridge structure of this type on our study of bridge engineering, the slab on girder structure type. A bridge superstructure consisting of a concrete slab resting on a set of girders which are connected by diaphragms to form a frame. So that is a slab on girder. There is a slab that is being supported by series of girders that will form a frame. The girder could be steel or precast pre-stressed concrete beams or of other suitable material. So these supporting diaphragms or primary members or girders can be made out of steel or precast pre-stressed concrete beams. Traffic passes over the top of the slab, which can be covered with a wearing surface, although sometimes the slab itself is made thicker to create an integrated wearing surface, like using a portion of the slab rather than a separate layer to resist the wear of traffic. So this slab that you are seeing here on a slab on girder type of bridge structure can be covered with a wearing surface. So there's an additional layer of surface that will be put on top of the deck, like bituminous material or asphalt. Although this wearing surface can be made uh, integrally with the superstructure itself, like the slab can be made thicker so that there will be no need to add additional layer of wearing surface. So the slab will just be made thicker so that there will be no need to put additional layer of wearing surface. So that's one type of bridge structure that is usually constructed. And actually, this is again the most popular on this time in the modern highway bridge time. Slab on girder is the most popular type of bridge structure that we usually construct nowadays. That's why we will be more focusing on the design and or engineering of a slab on girder type of bridge structure. So there are actually many advantages of using slab on girder type of bridge structure. So one of these advantages is this. One of the advantage of using slab on girder type of bridge structure is because the design of slab on girder is very simple. Its design is simple. From an engineering perspective, slab on girder structures do not break much new ground theoretically, but the complexity they offer from a total project perspective presents a challenge for any designer. So that's one advantage of using slab on girder type of bridge structure. It's because its design is simple. You don't need additional knowledge for you to be able to design a slab on girder. You can use the knowledge that you have earned from the previous designs that we usually encounter in civil engineering, like design of reinforced concrete, design of pre-stressed concrete, or design of steel members. You don't need additional theoretical background just for you to be able to design slab on girder. And that fact is actually an advantage of using slab on girder type of bridge structure. It's because its design is simple. You don't need again to have additional theoretical background for you to be able to design it. So that's one advantage of slab on girder. Another advantage is the slab on girder bridge lends itself well to a uniform design that can be standardized easily. Standardization minimizes the need for creating a plethora of codes and specifications for designers to follow, especially when many owners of bridges rely on private consultants to assist in the design of new and rehabilitation of existing bridges. Uniformity also means that consistent and therefore economical methods can be employed in repairing deteriorated structures. Imagine if a highway network had hundreds of unique designs with customized components for each structure. So this is again another advantage of using slab on girder. It's because its design can be easily standardized, meaning we don't need to have uh, a new set of codes and specifications for the designers to follow. We can easily standardize the design of slab on girder. We can easily make a uniform design out of the design of a slab on girder that can be easily followed by designers. We don't need to have to 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 have new sets of codes and specifications to follow just for us to be able to design a slab on girder type of bridge structure. So that's another advantage of using this type of bridge structure. Its design can be easily standardized. And due to that, we don't need to follow several series of new set of codes and specifications just for us to be able to design it. So that's another advantage of slab on girder. Another advantage is that construction is relatively straightforward and makes use of readily available materials. Prefabricated primary members such as steel wide flange stringers or pre-stressed concrete beams allow for quick erection and a clean appearance, and at the same time provide for an economy of materials that is a benefit to the contractor as well as the owner. So this is again another advantage of using a slab on girder type of bridge structure. It's simply because its construction is relatively straightforward. Its construction is somehow easy to be done. And in addition to that, the materials that are needed to construct it are usually readily available because there are prefabricated primary members such as steel wide flange stringers or pre-stressed concrete beams that can allow for quick erection of a slab on girder type of bridge structure. So that's another advantage of using slab on girder type of bridge structure. It's because its construction is simply straightforward. And actually, because of that, uh, since there is no special construction technique that is needed to construct a slab on girder type of bridge structure, therefore, the cost of constructing it can be minimized. And again, that is an advantage to the contractor as well as the owner. And as well as the availability of the materials that is needed. So you don't have to 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 fabricate specialized materials just for us to be able to construct a slab on girder. So that can save uh, money or cost to the contractor as well as the owner because of the readily available materials. So if there are advantages of using slab on girder type of bridge structure, there is also a disadvantage. So what is the disadvantage of using slab on girder type of bridge structure? The only advantage that we have here of using slab on girder structures uh, is it will be primarily used for short to medium span lengths up to 300 feet or 91 meters or for steel girders and 160 feet or 49 meters for pre-stressed concrete girders. So that's the only advantage that we have here of using slab on girder. We can just use this type for short to medium span lengths. So for lengths of greater length, I mean for spans of greater lengths, we have to use other type of bridge structure because again, the disadvantage of slab on girder type of bridge structure is that it is limited to short to medium span lengths. So another type of bridge structure that is usually used in construction is the one-way slab type of bridge structure. It looks something like this. For a very short span, like less than 30 feet or 9 meters, a one-way cast-in-place reinforced concrete slab supported on both ends by small abutments is an economical structure. So if the span that will be connected by a bridge is very short, like 30 feet or 9 meters, one-way slab type of bridge structure is an economical choice. So in a one-way slab type, we have a one-way slab here that is being supported by two abutments on each ends of the one-way slab. So when we say one-way slab, the slab just bends on one direction. That's why it's called one-way slab. The bending just occurs on one direction, which is this. For short to medium spans, like 30 to 120 feet or 9 to 36 meters, adjacent slab bridges, which are composed of precast prestressed concrete slabs, are the most common type of one-way slab bridges. So that is the most common type of one-way slab bridges that are usually used, which is the precast prestressed concrete slabs. The precast slabs may be of solid rectangular sections or box beams with longitudinal shear keys along their sides, so they will deflect together and share the live loads. So that is one-way slab type of bridge structure. It is composed of one-way slab supported by abutments on each end. So you usually use that for very short span of 30 feet or 9 meters. Another type of bridge structure is the steel and concrete box girder. So it looks something like this. It is just a box girder that can be made out of steel, or in this case, on this particular photo, it is made up of concrete. So that is usually used when bending and torsion are major concerns. So that box girder type of structure can offer an aesthetically pleasing, albeit expensive solution. Since these types of structures do not make use of standardized prefabricated components, their role is usually restricted to major highway bridges that can take advantage of their ability to meet relatively long span requirements. So we usually use box girder type of bridge structure for relatively long span uh, requirements. So you can see here that uh, although the only disadvantage of using box girder is it is expensive because there is no standardized way to prefabricate its components. Although, as you can see here on the photo, one of the advantages of using box girder, other than it is useful to for relatively long span, other than that advantage, uh, you can see here on the photo that uh, the space inside the box girder can also be used for additional traffic, although for light traffics only, like light vehicles or pedestrians. So the heavy traffic that will be accommodated by box girder can be put on top of the steel or concrete box girder itself, and then the clear space inside the box girder can also be utilized as additional pedestrian way or an additional road for light vehicles. So that can be another advantage of using steel or concrete box girder, other than its usefulness for relatively long span requirements. So another type of bridge structure that is constructed in a highway bridge site is what we call cable stayed. So cable stayed type of bridge structure looks something like this. Concrete or steel multiple cell box girders are commonly used for the superstructure of cable stayed type bridge structures. Although steel trusses and steel plate girders may also be used. Towers, also called pylons, are built with either solid or hollow concrete sections, depending on the tower size and the loads from cable stays. So the pylons or the towers are this part of the cable stay structure type. So the pylons or the towers are the ones which support the the superstructure or the deck itself. So as you can see here on the figure, the cables that supports or that support the deck or the superstructure are attached to the pylons or the towers. Superstructure may be designed to be supported at pylons with bearings, to be fixed at pylons, monolithic with pylons, or to be floating or no support at pylons. Low cost, ease of construction, and aesthetics are the major reasons why this type of structure is now a popular choice for medium and long span bridges. So one of the advantages of using cable stayed type of bridge structure uh, is it is good for serving long span bridges. So as you can see here on the figure, cable stayed type is used to support long span bridges. So again, as you can see on the figure, in a cable stayed type of bridge structure, the superstructure or the deck is being supported by cables that are attached to a tower or a pylon. So that is another type of bridge structure, cable stayed type. So another structure type or type of bridge structure that is usually constructed is what we call suspension type of bridge structure. So the most famous example of suspension bridge or suspension type of bridge structure is the Golden Gate Bridge that is that you're seeing here on the GIF or the figure. Trusses or steel box girders are typically used for suspension bridges. Vertical loads from deck are supported by hangers which are supported by main cables. Suspension bridges are very structurally efficient, thus they require less material than other types of bridges with similar span length. Because of their slenderness, detailed wind analysis is required to ensure stability. So in a suspension type of bridge structure, the superstructure or the deck is being supported by hangers. So these are the vertical cables that you are seeing here. So these hangers that you are seeing here are attached to a main cable, and then these main cables are attached to the main supporting towers. So suspension bridges are structurally efficient, meaning they require less material compared to the other type of bridges. Although suspension bridges are somehow slender, that's why they are critical with respect to wind or lateral loads. That's why whenever we design suspension bridges, we must ensure that detailed wind analysis is conducted so that we can assure that the suspension bridge will be stable. Because if we will not design the suspension bridge properly, uh, its fate will be maybe the same to the fate of Tacoma Bridge. So Tacoma Bridge is another famous suspension bridge that was built long ago before the construction of the Golden Gate Bridge. So you can search on the internet the words Tacoma Bridge, and you can see many articles and videos about it. So the Tacoma Bridge is another example of a suspension bridge. And if you can see on the internet, the Tacoma Bridge is a very flexible suspension bridge to the point that it it uh, it swings back and forth even though there is no major wind load that that is being experienced by the superstructure, or even though the traffic volume is just the or are just the users of the superstructure. You can see on videos that the flexibility of the Tacoma Bridge. So that flexibility actually became the reason of its sudden failure. So the Tacoma Bridge is actually one of the uh, most famous failures of bridge construction in the history. And although the failure that we had experienced on the Tacoma Bridge were not put into waste, because we have learned many things on the failures that our previous engineers experienced on the construction and the design of the Tacoma Bridge. Actually, our specifications, our codes that we use nowadays on modern highway bridges are actually built with the foundation on the failures that we learned from the design of the very flexible Tacoma Bridge, very slender Tacoma Bridge. So that slenderness, that flexibility became the cause of its very sudden failure. Another type of bridge structure is steel or concrete arch. So this is an example of steel arch. This is actually the Sydney Harbour Bridge that can be found in Australia. When the deck is suspended from the steel arch, the structure is called a through arch, just like what you are seeing here. This is actually an example of a through arch. So when the supporting arch is is located above the deck, so it's called through arch. When the deck is supported on top of the arch, this is called a deck arch. So if you can see a bridge with an arch located below the deck, that is actually what we call the deck arch. The arch is located below the deck. An arch bridge generates large reaction forces at its end supports. The horizontal component of these reaction forces is resisted by either abutment foundations or, in the case of a tied arch, a tie between arch supports. The highest point on an arch is known as the crown. So this is the crown. The highest point in an arch. In a true arch, the vertical cables from which the deck is suspended are called hangers. So these are the hangers. These vertical cables that you are seeing here. In deck arches, the area between the bridge deck and the arch is known as the spandrel. So if you will look on this true arch, although this is not a deck arch but a true arch, but you can already see here the word spandrel. You can see here the area that is being described by the word spandrel. So the spandrel is actually the area between the arch and the deck. So this is the spandrel or a deck arch, although this is a true arch. Deck arch bridges with open areas between supporting columns are known as open spandrel arches, while those that are solid between the arch and deck are called filled spandrel arches. The spring line is the extension of the arch from the abutment or pier support. So in this figure, you can see here an extension of the arch. So this is the arch, and this is an extension of the arch. That is what we call the spring line. So that is extended through that is extended to the abutment, up to the abutment or pier. The surface that the arch is supported on is inclined at an angle. This surface is called the skew back. The lower surface of an arch is the soffit. So if this is the arch, the lower surface, which is this, is called the soffit. And the upper surface, which is this, is called the back. So that those are just some of the major parts of an arch bridge. Arch bridge. So arch bridges are also useful for medium to long span bridges. So it can be made out of steel or concrete. The arch supports the arch support can be made out of steel or concrete. So the last structure type or the last type of bridge structure that we will study is the truss type of bridge structure. So the truss members of a truss type of bridge structure are typically fracture critical members, meaning there is no redundancy in the load path. So should one member fail, the whole structure would collapse. The construction and maintenance costs of truss bridges are very high. Due to this, very few truss bridges have been built in the past 50 years. So truss bridges are actually useful to carry heavy loads, heavy traffic, such as the railways of trains, such as this railway that you are seeing here on the picture. Although the disadvantage of using a truss type of bridge structure is that its members are fracture critical. So when we say fracture critical, it just means that if one member fails, the whole structure might collapse. So for a truss type bridge, maintenance is very important so that to ensure that every member of the truss is in good condition. Because as I've said before, the members of a truss is fracture critical members. So meaning that just means that whenever or should I say if one member of the truss fails, the whole truss structure will collapse. So there must be a very delicate maintenance of every member of the truss just to ensure that the members are in good condition. So due to this critical maintenance, this results in a high maintenance cost. In addition to the high construction cost of truss bridges. So due to this high maintenance cost of these truss bridges, very few of this type have been built in the past 50 years. So we don't usually build truss bridges nowadays due to the high maintenance costs. Although there are still truss bridges, actually in the Philippines, we can still see some famous truss bridges like the Ayala Bridge. So if you had been on Manila, you are very familiar with the Ayala Bridge, which is composed of steel truss members. So those are the different some of the different types of bridge structure that we we can build on a particular highway bridge site depending on the condition of that particular site. So on the decision of what type to be used depends on the different factors that I have enumerated a while ago, as well as the actual site conditions. So again, among those different structure types that we have discussed, the slab on girder type is the most common nowadays. That's why in our subject, in our course, bridge engineering, we will be more focusing on studying slab on girder type of bridge structures.